Right, so I'm going to be talking to you today about the maths behind Google Translate. We're not going to go too mathematical. We're keeping quite vague about this. So people don't know too much maths can keep track, because I know there's a few non-mathematicians there. I'm looking at you, Florent. So yeah, when I was at school, I learned French for 5 years and Spanish for 6 years, and I'd say I was all right at it. But there was always, whenever I didn't know something, I could go to a particular source, and that was Google Translate. It would always know more than I did. So Google Translate is amazing, because it can handle simple sentences. So if I get it here, it says translate I like cats, it can tell me j'aime les chats, French for I like cats. But it can do complex sentences as well. And this includes the subjunctive tense, which is something we don't have in English. It's quite a hard thing to understand, but Google Translate doesn't even flinch. And you can also translate several paragraphs in just seconds. So here are all of the lyrics to Carly Rae Jepsen's Cool Baby. Translation from native French. And again, no problem, just does it like a flash. So I realised something when I was learning French. Google Translate's better at French. A computer program was much better at it than I was. And that kind of bugged me. And so I kind of investigated it to work out where its flaws were. And I found out that it's not that much better at French than me. It's more better at maths. Because it's all maths, Google Translate. I'll explain how. So first I'm just going to reintroduce probability to you, or for those of you who haven't done probability, introduce it for the first time. Particularly conditional probability. Now if we look at these shapes up here, the probability, if I pick one of these things at random, that it's a blue ball, is 0.5, it's 1 in 2. There are 4, 2 of them are blue, half, easy. The probability to have a spot is 1 in 4, because only one of them has a spot. But the probability that the ball has a spot, given that it's already blue, is 0.5, it's 1 in 2. And so this way we can sort of adjust our probabilities, allowing for previous experiences. So here we've got P ball that has a spot, lying ball is blue. That means the probability that the ball has a spot, given that we already know the ball is blue. That's exactly what we're going to do to translate sentences. So what we're looking at is PFE. Here F is the sentence in French, and E is the sentence in English. So we're looking for the probability that the French sentence is what we're looking for, given that the English sentence is what we told it. So for example, if I put in the phrases j'aime le cat, chat, and I like cats again, we'll find that's near 1, because given that I like cats is what I'm looking for, j'aime les chats is pretty much dead on. But if I put in ou le bonk, that's completely wrong. There's nowhere near what I want. That's asking my language, that's useless. So that comes to about 0. So that's how the conditional probabilities work in these languages. And what we're trying to do is optimize this to try and get close to 1 as we can. So the other issue that we have here is that Google Translate might come up with different suggestions. J'aime les chats means I like cats, obviously. We've also got je les chats, which makes sense. It's not grammatically perfect, but it does mean I like cats. And the third sentence means cats are animals with 4 legs, which doesn't mean I like cats, but it might be something that's suggested. So we've got to try and optimize which is the best one. Now, calculating the best sentences, we're going to use Bayes' theorem. Now, you may have come across Bayes' theorem before, you may not. It looks like this, which is a lovely thing. But basically what it means is you can see we've got PAB and PBA. So we can basically flip conditional probabilities. If we know it one way, we can work it out the other way. So if you've already seen a translation one way, we can work it out back the other. So in our context, trying to find out the French translation given the English, if we already know the English translation given the French, say, just in case we did, and we can use that. I'm also going to factor out PE here, because that's the probability that the sentence exists in English. Now, given that I'm typing it into Google Translate, we can take for granted that it probably does exist in English. So we're actually going to be using this. So what we're looking for is the product between PEF, the probability that the English and French translation pair up the other way, and PF, the probability that the translation, that the sentence exists in French. Does that make sense?
Yes.
Ish? Good enough. So how do we get this data that we use to do the translation statistically? So what we're actually using is United Nations documentation, because they write down all 8 of the United Nations languages side by side. So we can kind of compare them. We can get the same document in English, in French, in Russian, in Arabic, Chinese, Spanish, and the other ones which I can't remember. And immediately you can start pairing up sentences and working out what corresponds to what. You can get those translations in. And we can do it word by word basis or on a sentence by sentence basis. We can also use EU documents, but they're not quite so well done, although they do cover 23 languages. So this is the core of what Google Translate uses, is the UN and EU. So you can trust them to do good translations, really. The problem, though, we have is the languages aren't one-to-one. if we have the sentence, I like, again, we're on I like cats, I'm sorry, I just got obsessed whilst doing this. If we have the sentence, I like cats, and j'aime les chats, you'll see that I like is 2 words in English, but j'aime is 1 word in French. And cats is 1 word in English, but it's 2 words in French. So these pairs don't really add up. If we were looking at it on a word-by-word basis, we might think that I means j'aime, like means lay, and cat means chat. But that's not true. So how do we counteract this? This is where n-grams come in. So n-grams are looking for phrases and patterns, not specific words. So we notice things like the word am is almost always preceded by the letter I. I am is a phrase, but am doesn't really get used elsewhere. In the French, chat is almost always preceded by lay. So we can use these to sort of notice patterns, and we start treating things as phrases rather than just core words. And so Google can start pairing things up even though they're not in a one-to-one relationship. And that's how we put things back together. And we can see this on Google Translate. If I open up a window here. I was in the house with my aunt is a phrase you can type in. And you'll notice that if I hover over the word here, j'étais, it shows that it pairs up with I was. It's treating this as a phrase, because it already knows I was translates to j'étais. It's not doing it on a word-by-word basis. It already knows that in the house can be said dans la maison, and with my aunt is avec ma tante. So what it's doing is breaking it down into different chunks and pairing them up, rather than doing it on a word-by-word basis and getting some sort of weird sentence of just direct translations. And that's where it sort of starts getting clever, rather than just trying to generically go through them. Now the next thing to do is evaluate these, because we've already done the translation. Now we've got the data, we can translate word by word or n-gram by n-gram and start pairing things together. We need to evaluate it as a whole sentence to see if it makes sense. So here's a chart of these are books from 1800 to 2000, and the blue line is the number of occurrences of I like, and the red line is the number of occurrences of I am liking. I am liking means the same as I like, effectively, but you wouldn't say it in English. And again, Google Translate can access this data. And so look at this graph and go, I want to be saying I like, even though I am liking might make sense, and it might be something that I've translated it as, I like is the correct sentence to use. So putting it all together, basically we start off getting a sentence out of cats, tokenizing it into I like cats, 2 phrases that we know we can get translations for. Then we get all of the different translations we might find, and we put them together. So we might get j'aime, j'aime, les chats, chat, put them all together. And then we evaluate all 3 of the different sentences we could have put together here and work out what the best one is. And that's how Google comes up with your translation. It breaks up your sentences into different phrases, looks at UN documentation to pull them back together and work out what the different phrases are, then puts it together into a sentence and works out which sentence suits you best. So in conclusion, I realised that Google Translate isn't better at French than me, because it doesn't know anything about linguistics. It doesn't know anything about the French language. I understand it, I know how it's put together. But to admit, it would beat me at statistics every day. If you want to find out more about Google Translate, there's Google Research has lots of very in-depth, fascinating papers that are a lot more mathematical than this talk was. So if you want to get some good product symbols in there, there are plenty of those. And also statmt.org has loads of great resources about different papers, different books, other presentations, all sorts if you want to learn some of the deeper maths behind it. But that's just a basic introduction to kind of the statistics that were behind it. And if anyone has any questions, I can try and answer them. Okay.